This video is about forecasting. Forecast is a statement about the future value of a variable of interest. And that variable of interest could be anything. It could be demand for something, quarterly demand, yearly demand, monthly demand. It could be about inventory related decisions. We make forecasts about such things as weather, demand, and resource availability. And because we do not have a crystal ball, we cannot just make some random guesses. Our forecasting should be scientific, it should be objective and based on data. And forecasts are important to making informed decisions. And in this video, I will explain different types of techniques that are used for forecasting. I will start with these three techniques: moving average, weighted moving average, and exponential smoothing using Microsoft Excel. I'll be using this data, and data is in this format. So we have day, 7 days of week, and in the next one, there is sales. And in the next one, it's about forecast. So sales is something that's actually actual sales, and forecast is something that we will do using some mathematical models. So in real life, for instance, let's say for Monday, 50 units were sold. On Tuesday, 52 units were sold, and Wednesday, 50 units were sold. And we have to make a prediction for Thursday. So by this time, I do not have a value for Thursday, but as soon as I will use certain mathematical models to make a forecast. But as soon as actual sale becomes available, I will fill it here. So this is how it works. I will make a forecast for Thursday using data of these three, Monday, Tuesday, and Wednesday, because these are only three values that are available to me. And so these forecasts, they will be filled in this column, in the last column. And as soon as when Thursday is over and you already have data for Thursday, then I will fill it here in this column. Similarly, as data keeps arriving for each day, we will keep filling this column. So this column, it represents actual sales data that's coming from your systems. And this column, that's about forecast, which means we will be making these forecasts by using mathematical models. And for the sake of this lecture, I'll be using this data. So in this data, we have days and sales. Now, we can imagine that at one point, this is not available and we have to make a forecast for Thursday. And the first technique that we'll be using is called as moving average. And I will be using 3-period moving average. And using this 3-period moving average, I will calculate forecast for Thursday. So 3-period moving average means that I'll be using 3 periods. And these 3 periods, that's Monday, Wednesday, Monday, Tuesday, and Wednesday. And using the data of these 3 periods, I will calculate average. I will calculate forecast for Thursday. And so accordingly, because I am going to do this forecast for Thursday, so remember, I will insert formula in this cell. I cannot start from here. I cannot start from here or here. It must be here because this is forecast for Thursday. So the cell in which I'm going to insert data is this one. And that will be equal to average. And I take average of these 3 values, close parenthesis, and hit enter, return. And that's 50.67. Now, in the same way, we will develop this whole series. And let's say 50.67. Now you can drag it down and this will give you forecast for the whole column. So this is called as moving average. And again, for example, let's say if we talk about this one, 50.67 is the forecast for Thursday. And when we were calculating forecast for Thursday, at that time, this 50, which is actual sales data, was not available. So therefore, we calculated forecast. However, when this data actual sale becomes available, we enter here 50. Now, in the next step, we are going to move this one step down, which means for Friday, I will be using these three periods, which mean Tuesday, Wednesday, and Thursday. Now this one that's 50.607 in the following one, this is the average of these three. And then so this is forecast for Friday, and when actual sales data turned out to be 55, we put it here. And so the idea is that why it is called moving average, because we keep moving one cell down. We started with this one, that was our starting point, and the average of this one is 50.67. And then in the next step, we calculate average of this one, 52 plus 50 plus 50, and then average of these one, and then average of these one. So in this way, we keep going one cell down. For this one, our forecast will be 52. So the average of 50 plus 55 plus 51, which mean adding them up and dividing by 3, that gives us 52. And similarly, after that, we will move to this one. And then after that, we will move to this one. So this is how moving average works. And this is the reason why we call it moving. A few more things. Why I'm using 3? I mean, is there a something for using 3? Can I also use 2-period moving average, 4-period moving average, 5, 6, 7? Yes, we can do that. And actually, we will do that. This is something, how we make a decision that it should be 3, 4, 5, 6, 7. This is called as trial and error. Okay, let me do it here very quickly. What will be our 5-period moving average? So 5-period moving average. So 5-period moving average means that I will be taking average of 5 periods. So what are those 5 periods? 1, 2, 3, 4, 5. So these are 5 periods. And therefore, my first forecast will be for Saturday. So I will select this cell, and then I will use the same method, is equal to average, and average of first 5, 1, 2, 3, 4, 5, and hit enter, and this is average of first 5 values. And remember, when I was calculating the average of the forecast for Saturday, it's 51.4. At that time, this actual value was not available. But when this actual value, that's 51, actual sales becomes available, then I will enter it here. And similarly, again, you can just double click this one and it will automatically fill these cells. So this is called as 5 moving average. In the same way, you can also do it for 7-period moving average, and which mean in that case, we will be doing it for next Monday. So these will be 7 days, and first forecast will be for Monday, and we will be using exactly the same approach. Now, how do we determine that what we should use? Should we use 3-period moving average, 5-period moving average, or 7-period moving average? Actually, these decisions are based on trial and error. We can calculate here 3-period moving average, 5-period moving average, and 7-period moving average. And later on, we will see which one is closest. So for instance, let's say, if I look here, this one, Sunday, actual sales was 52. And using 3-period moving average, it gave us 52, which is exactly the same. But moving 5-period average, it gives 51.6, which is less accurate than 3-period moving average. So therefore, we can say that in this case, only in case of Sunday, we can say that 3-period moving average seems to be more accurate compared to 5-period moving average. Okay, let's see another situation. Let's say if we talk about Friday. On Friday, our actual sales value is 60. And using 3-period moving average, we get 55. And using 5-period moving average, we get 53.8. So clearly, 55, that is 3-period moving average, is closer to 60 compared to 53.8. The distance between 60 and 55 is less, and the distance between 60 and 53.8 is more. So which means, again, just based on this one, it appears that 3-period moving average is a better choice. The same thing here on Saturday. On Saturday, we have actual sale value of 55, and 3-period moving average gives us 55. And 5-period moving average gives us 55.4, which is zero point 0.4 more than the actual value. So it looks like using these randomly selected few values, it looks like a 3-period moving average is more accurate. But we will be using more objective and scientific techniques. The next technique that we are going to use is called as weighted moving average. So the idea of weighted moving average is we have these three, and I want to calculate a forecast for Thursday. On Thursday, the sales value for Wednesday is more important because that represents the recent data. And the value for Monday is less important because a 2 or 3 old day situation. I mean, consider the situation. You want to make a prediction about weather. So which one would be more liable? So, and let's say if you want to make a prediction about weather using past data. So you have data about yesterday, you have data about 6 months before, you have data of 1 year old data. So which data is more likely to be accurate? Of course, the data that we had yesterday, because that reflects what would be the weather forecast for today compared to 6 months ago when it was an entirely different season, or 1 year ago, an entirely different situation. So we recognize this thing that as data ages, it loses its value. The more current the data is, the more valuable it is. So for instance, let's say in this case, Monday, Tuesday, Wednesday. So we already have these three, which means let's say today is Thursday, and we want to see that out of these three values, which one is more valuable? I would say Wednesday is more valuable because that is the recent one, and then followed by Tuesday. And Monday is least important, it's least current. So when we recognize this thing that as data ages, it loses its currency, relevancy, and value. So we want to assign them some weightage. We say, okay, if Wednesday is more important, let's give it more weight compared to Monday. Now, when we were doing moving average, in moving average, we are considering that all these three values, they have equal weights. Monday, Tuesday, and Wednesday, they have equal weight. That was the assumption of moving average. But we know this assumption is not true. So we want to assign them some weight, which means Wednesday will be assigned more weight because it's latest, and Tuesday will be assigned less weight because it's less recent, and Monday will be assigned lowest weight because it is the oldest. And in weighted moving average case, I'm going to use three scores, that 50, 30, and 20. And the total should be 100, as you can see here. So 50%, 30%, and 20%, and together they should be 100%. And Wednesday is latest, so I will give it 50% weightage. And then Tuesday is bit old, so I will give it 30% weightage. And Monday is oldest, I will give it 20% weightage. The formula will be is equal to Wednesday 50 times 50%. 50% is also called as 0.5 plus this Tuesday multiplied by 30%, and 30% is 0.3 plus Monday value, which is the oldest one, multiplied by 20%, which is 0.2. And if I hit enter, it gives me 50.6. And then again, just drag it or double click and the whole column will be filled. So this is our weighted moving average. I just wanted to tell you about one more thing. And if you click on data, by clicking on data, you will have data analysis. Sometime this is not available. So you see on the extreme right, if you click on data, tab in the ribbon, and then in data analysis. And if this is not available, don't worry, click on analysis tool. And if when you click on analysis tool, you will get this one, analysis tool pack. And there you can add it. So for instance, let's say you can also go to tools if you're using MacBook, and then you can say Excel add-in and analysis tool pack. And if you click OK, then this will appear. I have given here some, if you are using a MacBook, what you should use. If you're using Windows, what you should use. Tools at the top, and then Excel add-in and select analysis tool pack. And then this will appear here. And if you're using Windows, then on extreme left, click on File. And after that, you go in down further, click on Options. And after option, a dialog box will open. And in dialog box, you will have add-ins on the left side. And then click on Excel add-in and choose from that drop-down list, Excel add-in, and click go. And then another dialog box will open, and then click the analysis tool pack. And that dialog box will be like this one. So where you have analysis tool pack, etc. Now, using this function, we can also uh, calculate, we can also do forecasting. So for instance, when I click on this one, data analysis, here is moving average. So I can click on moving average, click OK. It says input range, which data you want to use. I want to use this data. So this data is automatically selected. It says are label in first row. So you can see here these labels, they are not selected. So I will keep it unchecked. Interval 3, because I'm using 3-period moving average, so I will write 3. And the next thing is that it's asking, where do you want your results to appear? I say, okay, I want my results to appear here in this column at this place. And if I click OK, you can see it has automatically filled in, and you can see that these results and these results, they are identical. So here you see not applicable. And not applicable, we know the reason, because we are using 3-period moving average. So therefore we don't have any for this one. And for the fourth one, that's our forecast. So if you round it off, you will see that this one and what we did, they are identical. So for exponential smoothing, I'll be using this formula. Our approach will be that for the first period, this is our actual data, same data. And for the first period, that's Monday, uh, nothing is available because, so I will just write it not applicable because on this day, actual sale was not available. And for forecast, we need some data to make a forecast because actual sale was not available until Monday was over. So therefore, we don't have any forecast available for Monday. And the first day we can have a forecast will be Tuesday. And for Tuesday, the only forecast was available is this 50. So which means the actual sale on Monday, it becomes forecast for 50. And from Wednesday, we will be using this formula, the formula that you can see here. Formula is equal to forecast is previous forecast plus alpha. Alpha can it range from 0 to 1. Usually we take 0.2, and then difference alpha will be multiplied by difference of previous actual sales value and minus previous forecast. So let's do it here, is equal to previous forecast, which means this 50, and plus alpha 0.2, and that will be multiplied by difference of previous actual minus previous forecast. Okay, I accept this change, and then we have this one. So this is called as exponential smoothing. And we can also do exponential smoothing using a predefined function in Microsoft Excel. So if you click on data analysis, we have exponential smoothing, click OK. And then it says, what is your input range? Input range is this one. And then damping factor. And damping factor, as you can see here, is equal to 1 minus alpha. Alpha is 0.2. So damping factor will become 0.8. This is how Excel works. and output range where you want your results to appear. I want my results to appear here, and if I click OK, it gives me this thing. So as you can see that they are identical. Everything is exactly the same. Which technique is better? Is moving average better, weighted moving, or exponential smoothing? Now, the answer to this question will come from another set of techniques we are going to study now. They are called as these three, which mean absolute deviation, or also called as mean absolute error, or we will just call it MAD or MAE, and mean squared error and mean absolute percentage error. Now, again, remember, when we are making forecasts, these are techniques for forecasting. And the techniques that we are going to do now, they are not meant for forecasting, but they are meant to assess the robustness of these three techniques. Now, let's say we want to see how much robust is this moving average. And I want to use MAD technique. And MAD technique, as I mentioned, MAD stands for mean absolute deviation. And this is also called as mean absolute error. Now, the idea for this one is that you just read it backward. MAD, you read it like DAM, dam. So what is D? D means deviation. Deviation of what? Deviation of actual and forecast, which means how much is the difference? So that's the first thing you have to do. And then A for absolute. Absolute is the same thing, which means taking away negative from a value. And M stands for mean or average. So the first is about difference or error. And here we go. That's the error of actual minus forecast. And this is our error, the difference between actual and forecast. And if I drag it down, this is the difference of column B and column C. And the next one is absolute value. As you can see here, this is negative 0.67, and this is negative because 50 minus 50.67, 50 is smaller and 50.67 is larger. So 50 minus 50.67 is negative 0.67. Now, I don't want this negative sign. I am only interested in 0.67, but not in negative, because negative is telling you the direction. It is telling that forecast is greater than actual sales. Similarly, if we talk about this one, 4.33. Now, 4.33 means that it's the difference of 55 minus 50.67, because 55 is greater. So 55 minus 50.67 is 4.33. So that's positive. Now here again, 51 minus 51.67, it's negative 0.67. Now we are not interested in this negative, because the thing is that in the next step, we have to calculate average. And if these negative signs, they remain there, they will be catastrophic. They will cause havoc. They will affect our average. So I want to eliminate these negative signs. Okay, for this one, we will use this one is called as absolute value, which means absolute of negative 0.67. And guess what will happen? If I hit enter, what will happen? This one will be converted to 0.67, and this negative will be taken away. So here you go. So everything is exactly the same, only that negative is taken away. I will do exactly the same thing. I will drag it. So you see, this column is identical to column E. The only difference is that these negatives have been taken away. Then the last one, as I told you, that when we are doing MAD, so the first step was different deviation. The next one was absolute value, and the last one was mean, which means no, we take mean. We take mean at the bottom, and it should be this one. Select this column and Control Shift uh, up arrow key, and it says that our mean is 2.89. So this is our value for MAD or MAE, 2.89. It is a three-step process, and in the first step, I calculated difference. In the second step, I calculated absolute value, and in the third step, I calculated mean. So the question is that can I combine these steps in one column? Yes, we can. So let's do it. I will write here MAD, or also called as MAE, the difference of 50 minus 50.67. That's the deviation part. And the next one is taking absolute. So I will add here ABS. And if I hit enter, it gives us this one, 0.67. And if I drag it down, it gives me this one. And if I want to calculate what is the average of this one, you can see that's also 2.89. So that's identical to this one. So which means that we have this option to do it in separate separate columns, but that's rather clunky. Therefore, I will try to combine all these in one column. So I'm going to delete this one. So this is called as MAD or MAE. And now what about if I apply this technique to weighted moving average, which I have hidden here. Let me unhide it. So this is, now here I'm going to use MAD for weighted moving average data. And this is our weighted moving average data. Now I'll be using this data. The rule remains the same, which means I will be taking absolute is equal to absolute, and then the difference of actual is this one. And remember, we are going to start from those values that are available. We cannot start from 50 because for 50 we do not have corresponding 50 moving average. We do not have a weighted moving average corresponding to a 50, 52, and Monday, Tuesday, and Wednesday, because we have values only available from Thursday. So this calculation, it should start from Thursday, is equal to absolute actual value 50 minus weighted moving average. Okay, and if I hit enter, let me expand it a little bit, adding more decimal. And we have this one. Now I can write here a formula, or I can just drag it here, and that is 3.32. Now we are done with this one. Let me also reduce its decimals. Okay. Now we have here MAD for 2. This is for moving average, and this is for weighted moving average. So this is mean absolute deviation or error. So in other words, these two values, they represent error or deviation. And as you can see, the deviation is less in case of moving average. This is moving average column, but this is more. That's 3.3 is more than 2.89. So 3.32 is more in case of weighted moving average, which means that when we compare our moving average and weighted moving average is a better one because it gives less error. It gives you results that are more closely related to actual values. And where are actual values? Actual values are in column B. So this is the way how we choose which type of technique to use. So I will repeat this whole process. It says we calculated mean absolute deviation. Again, that's about difference or deviation of the forecast against actual, and it turns out to be 2.89, and this is for moving average. And when we apply the same technique to weighted moving average, then we get 3.32. 3.32 is larger, which means deviation or difference is larger. The difference between actual sales value and forecast is much higher than this one. So therefore, we should stick to this one, to moving average. In the same way, for instance, let's say if you are using, this is 3-period moving average, right? Here you can see here 3-period moving average. You might have done 5-period moving average, 7-period moving average, 2-period moving average. Then how you are going to select 2-period, 3-period, 5-period, 7-period, which one? Again, we'll be using this technique, and we will see whichever gives the lowest value, we will choose that technique. Now we'll go to the next technique. Let me hide this. Now the next technique is called as mean squared error, or I just write it MSE. Now the idea of mean squared error is that, again, how to do that? You just read it backward, like ESM. So E means error or difference, So the difference between actual sales value and your forecast, square. When we will take error, when we take when we take difference, deviation, there will be some values that will be negative, and we don't want those negative values, because that negative, it will affect our average. So we don't want that. So we want to get rid of that negative. And for that purpose, we had two options. One option was that we take absolute, that we just did. And the second thing is that we take square. And if you take square, all these negatives, they will be converted into positive. And the last step is mean. That's taking average. So again, we can do it in a number of ways. The first thing could be that, let's say if I take its difference, I'm just doing it for demonstration. At a later stage, I will remove this one. And just to explain this, that difference or error part is equal to 50 minus 50.67. And we know this thing appears. And in the next, I want to get rid of this negative. So I will take squared. Mean this is equal to negative 0.67. And then if you press shift 6, you will get this type of symbol. And then 2, power 2. And if you hit it, it will give you this one. Let me reduce its decimal. So we have this 0.44, and if I drag it down, you get this one. So again, you can see here, there are no negatives here. And then we can take its average here, mean, which means this one, command shift up arrow key, and it's 12.95. Now, which means when we are using MSE, mean squared error, then our answer is 12.0 to 12.95. Okay, now can we combine? No, you see, we have our process comprises two steps. In the first step, we calculated difference, and in the second step, you calculated a square, and in the third step, we took average. So can we combine these three steps in one column? Yes, we can. And how to do that is equal to, so let's say difference of is equal to difference of 50 actual minus forecast. And here press shift 6, which means power, and 2. So that's a square, and let me reduce decimals. And if I, so you can see that this column and this column, they are identical. And then if I drag it, so this is mean, again, you can see these are the same. So we can do it in two ways. One thing is that doing it separately, one for difference column and then taking square, or the other thing is that doing all these things in just one column. That's a smarter way. So I'm going to delete these two columns because they are redundant now. Delete. And this is called as mean squared error. And mean squared error is 12.95. Now, I can also do the same thing with data from weighted moving average. And let's see what we get. So this is mean squared error using moving average data. Okay, and let's see mean squared error using weighted moving average data. And for that purpose, I need to unhide. Okay, here we have weighted moving average data. We have too many columns, so make sure you keep hiding some of the columns to get everything in view. And the approach is at 50, and that's actual value minus 50.6, and then a shift 6, which means power. And then if I do this one and I drag it down, and then average, its mean will be, I'm going to select this column, and that's 16.108. Now you see here, for the earlier one, the earlier one, when with moving average, it was 12.95. And with weighted moving average, it's 6.10. So what does it mean? What is the implication? The implication is that this technique, that's weighted moving average, is less accurate compared to moving average. And we had also come across the same conclusion when we were using MAD. In MAD, we also had the same conclusion that moving average is a better technique compared to weighted moving average. And this technique, that's MSC, it also gives us the same result, that moving average is better because that gave us 12.95, but weighted moving average gives us the higher results, 16.10. So which means I am not going to use weighted moving average for this one because it's less accurate. So no matter whatever technique they will give you the same results, which means your conclusion would be same. The numerical values will be different. Okay. And now the last one is using MAPE. So the idea of MAPE, E means error. Okay, I'm going to take error, which means 50 minus 50.67. Okay. Then what comes after E? Percentage. Okay, which means divided by this original actual value, that's 50. Okay, that's percentage. And then it's A, absolute. I will add here A, and I will add more parentheses. And the last thing is M, mean or average. This is something we have to take at the bottom. So we are done. So so you can see here, it's already there, 5.02. So this is the way how we calculate a mean absolute percentage error. And this is a mean absolute percentage error using moving average. If I apply the same technique to weighted moving average, uh, this result will be much higher for weighted moving average, because this is same thing we came across in MAD or MSC. We have done all these three techniques. And again, here is a reminder that when we talk about forecasting, these are forecasting technique: moving average, weighted moving average, and exponential smoothing. These techniques, that's MAD, MSC, and MAP, they are not meant for forecasting. They are not forecasting techniques, but they are meant to measure the accuracy, robustness, or adequacy of those techniques. Our next technique, that's called as correlation and regression. Correlation is basically also a technique that helps us in making decisions about forecasting, because in forecasting we have different types of variables, and we want to see what's the relationship between them. And in this one and in the next one, that's a regression analysis, you need to remember there will be independent variable and a dependent variable. So these are the terms that we will be using in correlation and regression. So let's say, for instance, here is we have data about mortgage interest rate and home prices. So for example, let's say, and this is mortgage interest rate, and then home prices, median home prices, and we have been given year, and this is at in 1988 interest rates were 10.3%, and then a median home prices was 183. And then at another point, let's say 1995, interest rate was 7.9 and median price was 169,700. And in 2003, interest rate was 5.8, and median prices is almost double, 329,800. Okay, and we want to see if there is a correlation between them or not. So here in this case, our independent variable is interest rate. That's independent, and home prices depends on interest rate. If interest rate is very high, people may not be buying houses because they would say, okay, interest rate is very high, we don't want to pay extra, so they would like to withhold. So home prices depends on interest rate, therefore this is a dependent variable. Interest rate is an independent variable, also called as X variable, and median price is dependent variable. And for this purpose, it's a very straightforward. You just write a correl, which is abbreviation of correlation, you can say. And then Microsoft Excel will automatically suggest you that array one. So let's say if I say this one, I select this one, and then comma, the other one, And then if I close parentheses and hit enter, it says negative 62%, which mean, first of all, let's only look at 62%, which means there's a good correlation, there's a strong correlation, or we can say like a moderate to strong correlation. 62% is a big number. There's a correlation, which means if one thing changes, the other one will also change. And the next thing is that you see it's negative, which means when if one increases, the other one will decrease. And if this one decreases, this one should increase. And of course, that's very intuitive. It makes sense. If uh, interest rate it goes down, median house prices will increase. And if it goes up, interest rate is high, then people won't be buying houses much. Inventory would increase and home prices would drop. So there is a negative correlation. One increases, other decreases. One decreases, other increases. And this is called as correlation. Now, this is one way, and then there is another way, again, using the function data analysis. You click on data, and after clicking on data, you go on data analysis. And in data analysis, in this window, correlation. So if you just click correlation, then it will ask, okay, which data? Where is your input range? This is my input range. And you see, I have only selected data. I did not select labels. So it says labels in first row. No, I did not do that. And then it says output range. Where do you want your results to appear? I want my results to appear, let's say here. And if I click OK, it gives me this one. It makes a correlation table, a matrix, which means the relationship between column 1 and column 1, which means that's always 100%, so you have 1. And the relationship between column 2 and column 2, again, that's 100% or 1. These are redundant, not needed. But the one that we need, that the correlation between column 1 and column 2, that's 62%. And that's the same thing that we have already figured out when we did it manually. And I can again convert this one into percentage by clicking this one, and that will be 62%. Now the last one is about regression. So regression is one of the most commonly and most valuable tool for making prediction. We'll be doing it on Microsoft Excel. This is a formula which means y is equal to a plus bx. A is intercept and b is slope. Y is dependent variable, x is independent variable. And if there are multiple independent variables, we will write it like this way. Y, which means dependent variable, is equal to intercept. Intercept is the point. Let me explain here. So intercept is the value of y when x is 0. So you can see here that, for example, here, this is y-axis and this is x-axis. When x is 0, y is 20. So we would say intercept is 20. And the next thing is slope. This is slope. How steep it is. Is it very steep, or is it a flat one? So that's called a slope. In other words, we see when we move on x-axis from one point to another one, how much change happens in y. So when you move from 0 to 1, how much change is happening? So at 0, it's 20, and at 1, it is something 22. So which means when you move from 0 to 1, it changes from 20 to 22. And when I move from 1 to 2, this is 22, and then it becomes 24. So you see there is a difference of 2. Every time I move on x-axis by 1 degree, then the corresponding increase in y-axis is of 2 points. That is called a slope. And this is the equation that we'll be using. Or one of these two equation, y is equal to y is dependent variable for which we have to make a forecast. A is intercept, b is slope, and x is the value of that independent variable. Okay, let's go back to our data. Just to give you some perspectives on this data, this is the data about transit demand. Let's say, for instance, that there's some metro bus service in a city, and you want to make some a prediction how many weekly riders they will be using metrobus. Because let's say you are working for the city government, and they want to make a decision, or let's say you're working for the metro company, and you want to make a decision about prediction that what would happen to the demand, how many riders they will be traveling. And then you calculate data for all relevant factors that would be affecting this one. And you see, one thing is price per week. Okay, because price is an important factor, and that determines that should people use metro or they should not use. Then population of city. Of course, it is another factor that determines how many people will be using metro. And then monthly income of riders. Of course, if monthly income is high, maybe people would be using their own transportation means, cars. And then about average parking rate per month. In this case, which appears to be a complex one, we have one variable in which we are interested. That's how many weekly riders will be using that metro service. And then we have data about all other independent variables that are likely to affect our independent variable. So independent variable is represented by y, and independent variable, they're represented as x1, x2, x3, and x4. And we want to make a scientific decision based on data. And we also want to make an equation. And again, for this purpose, I'll be using the same data analysis Excel add-in. Let's go for a regression analysis. And for that purpose, click on data. And after that, click on data analysis, click on regression. Okay. Now here's a dialog box, and it says input Y range. Now for input, we put only Y range. Here's our Y range. It has been selected. It's in column B. And then says X range. For X range, this is our data, and the whole is selected. That's from column number C to F. Labels, no, I didn't select label. Output range, where do you want your results to appear? Let's say if I say I want my results to appear here, a column H10, and when I hit OK, it has given me these results. Now, the interpretation of these results is that there are many things of our interest, but let's go to the most important one. The most important one here is this one, R square. So R square, which means the relationship, that's 94.5%. I can also convert it into percentage. So you can see here that this is the relationship, which means it says that this is a very good model because it's making very good prediction. 94.55 is a very good number, which means that this model, it explains that these predictors, independent variables, they are determining y variable. So that's R square. And then it says there are 27 observations, which means we have 27 rows containing data. We don't need that. And then next thing is that we have to make an equation, and that's one of the critical part. I have made this equation, which means forecasting. Forecasting for number of weekly riders is equal to intercept. This is our intercept. And again, let me use a different color this time. So this is our intercept, which means 100,000 and 222.6. So which mean when the value of x is 0, then this is the value of y. So this one comes here is equal to forecast for number of weekly riders is equal to intercept, which is this number I take from here, and then plus slope of first variable, and first variable is price per week. So this is price per week, and slope is negative 689.53. So negative 689.52 multiplied by price per week. That's the name of the variable. Okay, and then we move to the next variable. And for the next variable, slope is 0.05. 0.054. So 0.054 multiplied by the variable that's population of city, and we already have data about this on population of city. So at this moment I'm just writing, making an equation, and then the slope for the third variable. The third variable is monthly income, that's x3. Okay, for monthly income, that is this one, the slope is negative 1.3. So I will write here plus 1 negative 1.3 because it's in negative, multiplied by monthly income. And the last one is our this variable x4, that's average parking rate per month. And for this one, slope is 152.45. So it will become 152.46 if you round it off, and multiplied by average parking rates. What is the utility of this equation? So first of all, the most important thing is that this thing, which mean that these predictors, I mean, when you were making these choices that, okay, these are our independent variables and this is dependent variable, do these independent variables really have an impact on this one? The model shows yes, they do. So that's one thing. And then the second thing is that we want to know how much. This is a general equation, and this is when we substitute values. This is the slope and then price per week. I want to see what would happen if that's price per week, it falls to 10. I will write here 10. And then population of city. And then let's say if I say, okay, what would happen if population of city, let's say currently I can see it's something 1.8 million, 1.7. What would happen if it goes to uh, 2 million? Okay, I will write here 2 million. Okay, what about monthly income? 4,000. I will write here 4,000. And then the last one is average parking rates. So what about if this increases to 90? And if I solve this one, it will give me the number of riders. The answer at the end of the day will be number of riders.